Part 1. A relatable intro that pulls you in. Have you ever imagined a world where you can just make anything you want right from your own room? From phone cases, toys, even small machine parts. It sounds like something from the future, right? But the truth is, it's already here thanks to 3D printing. But at the same time, a lot of people are still confused. How does this thing actually work? How can a digital file suddenly become a real object? Is it just like a regular printer but in 3D? Or is there something more complex going on behind the scenes? And honestly, that confusion is totally normal. Because 3D printing often looks like some kind of tech magic. But if we break it down slowly, you'll realize it actually makes a lot of sense. In this video, we're going to walk through it together. Starting from the very basics, all the way to the deeper details that most people skip. We'll also explore how this technology is changing industries, businesses, and even jobs. Think of this as a journey, from an idea in your head, to a digital design, and finally into something you can actually hold. And the best part is, this is not just for big companies anymore. Today, creators, students, even hobbyists are already using 3D printers. So if you've ever been curious, or maybe thinking about getting into it, this video will give you a strong foundation. Because once you understand how it works, you'll start seeing the world differently. You're not just a consumer anymore. You can become a creator. And it all starts with one simple question. How does 3D printing actually work? Part 2. A quick story behind 3D printing. To really understand something, sometimes we need to go back a bit. Because every big technology has a story behind it. 3D printing started around the 1980s. An engineer named Chuck Hull created a method called stereolithography. The idea was simple but powerful, using light to harden liquid resin layer by layer. From there, the technology kept evolving. New methods started to appear. One of the most popular today is FDM, or fused deposition modeling. Why is it so popular? Because it's cheaper, easier to use, and perfect for beginners. Back then, 3D printers could cost hundreds of thousands of dollars. Only big companies could afford them. But now, with just a few $100s, you can already have one at home. This shift is similar to computers. They used to be huge and expensive, but now they're everywhere. And here's something interesting. The open source community played a huge role. People shared designs for free, so others could learn and improve them. This shows that 3D printing is more than just tech. It's a movement, a shift toward a world where production is no longer controlled by big factories. Imagine a future where you can just print what you need. No waiting, no shipping delays. That's why understanding how it works is becoming more important than ever. Part 3. The basic idea behind how it works. Now let's get into the core idea. How does 3D printing actually work? Imagine building something using Lego. You don't build everything at once. You stack it layer by layer. That's exactly how 3D printing works. First, you need a digital design, usually made with 3D modeling software. The file is often called STL or OBJ. Then this file goes into slicing software. Here, the model is cut into hundreds or even thousands of thin layers. Each layer becomes instructions for the printer. Then the printer starts working. In FDM printers, plastic filament is melted and pushed through a tiny nozzle. The nozzle moves around, following the path from the file, creating the first layer. Then the next layer goes on top, and the next one, and the next one, until the object is complete. This process is called additive manufacturing, because material is added, not removed, which is very different from traditional methods that cut material away from a solid block. What's really cool is the level of precision. Some printers can go down to tiny fractions of a millimeter. That's why 3D printing is used in medical tools, industrial parts, and even aerospace components. And all of that comes from stacking tiny layers, over and over again. So when you watch a printer working, you're actually watching something being built from nothing. Part 4. Different types of 3D printing. Not all 3D printers work the same way. There are different technologies for different needs. The most common one is FDM. It uses plastic like PLA or ABS. It's affordable and beginner-friendly. Then there's SLA. It uses liquid resin and light. The results are smoother and more detailed, but it's more expensive and a bit more complex to use. Then we have SLS. This one uses powder material that gets fused with a laser. It's usually used in industrial settings. Each method has its own strengths. FDM is great for quick prototypes. SLA is perfect for small detailed objects. SLS is better for large-scale production. It's kind of like kitchen tools. A knife, an oven, and a blender. Each one has its own job. And in real life, companies often combine these technologies. For example, they might prototype with FDM, then use SLS for the final product. So understanding these differences helps you choose what fits your needs best. Because there's no one perfect option, only the most suitable one. Part 5. Real-world examples. Now let's see how this is used in real life. In the medical field, 3D printing is used to create prosthetics, custom-made to fit each patient. In some cases, doctors even print organ models, so they can practice before surgery. In the automotive industry, companies use 3D printing to create prototypes quickly. What used to take weeks can now be done in just days. In the creator space, people are making unique products, custom figures, accessories, and useful tools. Some even turn it into a business, selling their own designs. And here's the crazy part. In some countries, houses are now being printed. Yes, actual houses. This shows something important. 3D printing is not just an extra tool. It's changing how we produce things. From mass production to customization. From factories to personal creation. Part 6. Common mistakes and the right mindset. A lot of people think 3D printing is instant. Just click and it's done. But in reality, it's not that simple. There are many factors that affect the result, like temperature, speed, and material quality. Even small mistakes can cause failure. Maybe the layers don't stick, or the shape becomes warped. That's why learning 3D printing is like learning a new skill. It takes time and practice. The right mindset is to treat it as a learning process, not just focusing on the final result. Because every failure teaches you something new. And over time, you get better and better. Just like a chef learning from every dish they make. That's where the fun is. You're not just printing objects, you're building skills. And once you get good at it, the possibilities are endless. You can create your own products, start a business, or even innovate something new. So don't be afraid to start. Every great creator was once a beginner. If you enjoy content like this, hit subscribe and like to support the channel, and share this with someone who needs this kind of insight. Part 7. Diving deeper into materials and how they behave. Now that you understand the basic process, let's go a bit deeper into something very important. The material itself. Because in 3D printing, the material is not just something you use. It directly affects the result, the strength, and even the purpose of the object. Let's start with the most common one. PLA. PLA is popular because it's easy to use. It melts at a lower temperature. And it doesn't warp easily. That's why beginners usually start here. But PLA is not the strongest material. It's more suitable for visual models or light-use objects. Then there's ABS. This one is stronger and more heat-resistant. But it's also trickier to print. It can warp if the temperature is not stable. So right away, you can see something interesting. Choosing material is not random. It's a decision based on purpose. Now let's go a bit further. There are flexible materials like TPU. These can bend and stretch. People use them for things like phone cases, wearables, or parts that need flexibility. There are also advanced materials, like carbon fiber-infused filament, or even metal-based printing in industrial setups. And here's the key insight. the same printer can behave very differently depending on the material you use. It's like cooking. Using rice or flour gives completely different results. So when someone says, "My print failed," sometimes it's not the printer. It's the material choice. Understanding materials is like unlocking the next level of 3D printing. Because now you're not just printing shapes, you're controlling how those shapes behave in the real world. Part 8. The hidden role of slicing settings. Earlier, we mentioned slicing software, but we didn't really break down how powerful this step actually is. This is where a lot of the magic happens. When you import your 3D model, the slicing software gives you full control, not just over shape, but over how the object is built internally. For example, infill. Infill is the structure inside the object. From the outside, it looks solid, but inside it can be hollow, grid-like, or even honeycomb. Why does this matter? Because it affects strength, weight, and printing time. A higher infill means stronger object, but also longer print time and more material used. Then there's layer height. This controls how thick each layer is. Smaller layers mean smoother surface, but slower printing. Larger layers mean faster printing, but rougher finish. There's also print speed, temperature, support structures. Each setting is like a dial, and changing one affects the others. This is why two people using the same printer can get completely different results. Because slicing is not just a step, it's a strategy. And the more you experiment, the more you understand how to balance speed, quality, and strength. This is where beginners usually struggle, but also where they grow the most. Part 9. From file to motion. How the printer moves. Let's zoom into the machine itself. Because once the slicing is done, everything becomes physical. The printer receives instructions in the form of G-code. Think of G-code like a language, a set of commands that tells the printer exactly what to do. Move here. Extrude this much material. Raise the nozzle. Cool down.